Hello, it's Scott Manley here, back with questions from my supporters over at Patreon. So this is episode 7, and I'm still working on the same post. Some of these questions are months old, but you know what? The answers are always fresh. So we're going to start with Andrea Sperini, who is asking about the consequences of a hypothetical light-speed capable spacecraft. What would we see if we could observe such a ship leaving this solar system at the speed of light? Wow. So yes, this is a hard one because, look, we don't know how to travel faster than the speed of light, so we don't necessarily know how it might actually look if such a thing was even possible. But one idea that might make it possible is, of course, the warp drive that was designed by Miguel Alcubierre. And actually, there's a cup up there behind the Atlas, just there, that he signed because I met him a few years ago. Now, he never really designed something. What he did was he came up with a geometry of space-time which could allow an object to appear to travel faster than light in some frames of references. That's not necessarily the same thing. But the thing is, there's been a few variations on this, but what you're doing is basically compressing space in one place and expanding space in another, and the spacecraft appears to move. Now, what this does is it basically bends space-time, and there are some videos showing how this tends to look, and you'll see basically, imagine a very weird gravitational distortion moving in front of something. Now, if something's going away from you, I'm not sure what you'd see, but I do know that one of the problems that was raised with this was that if it was coming towards you, as it comes along, the compressed area of space in front of it apparently collects interstellar dust and radiation and particles and things like that. And as soon as you slow down and come out of warp, all of this gets released as a huge, high energy blast of energy. So if it's coming straight towards you, you get incinerated. Or maybe you just get, huge doses of radiation. Yeah, this is a whole thing that is very hard to talk about, but yeah, it's a very cool subject. Yaroslav Kurakin is asking, you made a video about the Gateway Foundation about 2 years ago. They recently had a funding event and raised 1 million. Good for them. Do you have more thoughts about their project? So look, my thoughts about their project is that I think it would be great one day if people actually built an amazing wheeled type space station. I think that is a long way off, for the reason that any interesting application in space is going to exploit the fact that there is zero gravity. The things that do need gravity in space are people that want to live there and work there for long periods of time. And in that case, if you had, say, ships being built in space and people having to live there for very long times, then wheel-type space stations start to be a relevant idea. But then, you have to ask, well, is it not just cheaper to keep flying up new people? What I'm saying is it's one of these things that it's probably not happening anytime soon, and it's very hard to find a reason for it other than, say, movies like 2001 where the docking is really cool, or Elite where the docking again with a rotating space station is cool, or try to save money on your sci-fi movie budgets because, you want to not have people floating around in zero G. Anyway, obviously, as long as people are interested in this, I'd love to see it developed. Greg Citizen, good citizen, I don't know, citizen? Oh my god, I'm sorry, Greg, thank you. Hi, Scott, enjoy your videos, you're a terrific explainer and researcher. My 2 questions. Why do ascending rockets make a crackling or metal banging clanging sounds? Okay, well, that one I can answer. Or actually, that's not true. I can answer by saying we're not actually sure, I believe, what causes the crackling sound. There's a bunch of different theories, and it's very hard to actually formulate exactly what it is, as I understand it. But when you've got a rocket exhaust coming down, you've basically got a supersonic jet coming through a static medium around it. And at the very edges, you start to get these vortices, right? Turbulence that's generated. And apparently, it's believed that the frequency of these vortices, these produce the banging, the big crackling sounds. But I don't actually know very much about this. I think this was a thread by Chris Combs that threw that out there. But the second question that you asked here, I still see people claiming that the Soviets came up with this Buran design independently of the US space shuttle. A video to explain this why this is highly unlikely. Look, so first of all, the Soviets did come up with spaceplane designs independent of the US space program. They came up with the Spiral program, or the BOR, the BOR spacecraft, and that was all independently designed and developed on their own. But for the Buran, so the Buran entirely was a response to the US building the space shuttle. And according to the internal histories, the person that's always the expert on Russian space or Soviet space history is Boris Chertok. Look up his works. Anything that references him is generally good, worth reading. So the idea of the space shuttle, it was basically the Soviet academics were asked about this US space shuttle. What could it be for? And nobody apparently could come up with a convincing reason to build such a huge spacecraft with such a huge cargo bay with crew on board if it wasn't for military purposes. And because it became a potential military application thing, that it was decided that they had to build an equivalent thing with a similar cargo capacity and a similar crew capacity. And so, of course, they set about designing their own. And the problem was, it wasn't that they were stealing the US design, but that they basically tried and looked at a bunch of different designs, and it turned out that the US, for those constraints with the cargo bay and the crew and the cross range, had pretty much got as close to perfect as they needed to be. I mean, there's a few things you would change with Shuttle too. I think you would move those the rudders, the horizontal stabilizers or the vertical stabilizers to the wingtips, and that would actually give you better performance at high angles of attack because you wouldn't have the huge body sticking out there. You would also have redundancy and things like that. But yeah, the Buran, the aerodynamic design was very much chosen based on what worked, and what worked was what the US had already developed. Now there are some differences. I mean, and there's no engines, the propulsion system is different. But at the same time, broadly speaking, there's a lot of heritage between the Buran design and the US design. Now, and to be fair, there's a lot of structural differences inside. They're very different aircraft. But yeah, the Spiral one, that's much more interesting because that went the opposite direction, right? The BOR space planes, those were investigated, tested, and had test flights. And then after the Cold War, the US started getting interested and they took those designs and they built their own versions. And now, Dream Chaser, which is getting ready to fly cargo to the space station, that is pretty much based on the Russian design. So even if the Soviet Union, borrowed the design of Buran, the US is borrowing the design of the BOR. So, it's all, there's only so much you can do with the laws of physics, right? There's going to be a certain amount of borrowing that's required just due to having to fit in with the laws of physics. Okay, Jonathan Stevens says, "Hello, Scott," and spells it correctly. "So we enjoy your videos and are interested in what books are on your bookshelf. Look at it here. We have just got our first James Corey and N.K. Jemisin novels, good job, and wanted to know what you would recommend." So, I can tell this question came after I started recording this series because, of course, I immediately commented that nobody was asking me things like my favourite books. But anyway, yes, this is basically a pile of books that I have in my collection from various things. I have plenty of other books. I was just needing stuff to fill the backdrop, and so I put these in here. But yeah, I've got the Expanse novels. I've got Philip K. Dick, Iain Banks, lots of Dragon Riders of Pern. And there's an important thing the reason I have all the Dragon Riders of Pern books is because the author, Anne McCaffrey, sent me them because we worked together on the final book, Skies of Pern. I actually created the scenario where the asteroid hit the planet and came up with a bunch of numbers, and there's a map that we created inside it. Look here, my book has an insert showing where the tsunami would actually go in around Pern. So yes, But at the very start, there's a little signed version. This is like a leather-bound copy that she sent me as thank you. I think it's number one. Yeah, it's number 3 of 20. You see? So anyway, books that I actually read or recommend. If you're looking for science fiction, I highly recommend Iain M Banks, which Iain M Banks does things like Accession, which is my favorite Iain M Banks book. It's not the one you should start reading. His books are basically high opera, space opera, sci-fi in a futuristic society which is so much energy and resources that you can do anything. It's a post-scarcity society where anyone can do anything they want, and the machines, the minds, sit over humanity or the species as a benevolent overseers, right? And so I think the first book is Consider Phlebas, which is much easier to get into. By the time you get to Accession, you have to absolutely understand the minds, because this is largely told from the point of view of these benevolent supercomputers, the minds that are in charge of everything. And there's just so many cool ideas that are in there, and I would just love to see this rendered in some photorealistic version. Amazon started looking at it a while back, but they decided not to do it because Iain M Banks, who's fans? Elon Musk, Jeff Bezos, right? I don't know. You just keep on seeing references. When Richard Garriott went to the bottom of the ocean, the submarine that he used was called The Limiting Factor, which is again a reference to Iain M Banks. Now, to be clear, there's actually Iain M Banks and Iain Banks, and Iain Banks wrote contemporary fiction, which was also very dark and completely different. And the thing is, it was the same person, but the audience for one set of books wasn't necessarily interested in the other set of books, which is really funny. There's a few other books that he wrote that were not in the culture universe, the Algebraist, and what else? Against Dark Background, which is kind of cool in a lot of ways. Anyway, but I've been reading a lot of non-fiction, and I have one that I finished just recently. This is Eric Berger's Liftoff, which is it's basically the early days of SpaceX, how they got to launch. And this is Mike Mullane riding rockets, which is great. And you know what? There's another one that I should recommend, and that is Michael Collins' Carrying the Fire, which is one of the best works about space flight out there. Anyway, there's so much to read. I wish I had time to read it all. George Hill. Out of the two Scottish launch companies, Orbex and Skyrora, which rocket do you like the idea of most? I'm an Orbex fan, mainly because Skyrora is doing this hydrogen peroxide kerosene thing, and they end up having to have a much bigger and heavier rocket. And I think the Orbex design is interesting because it's using propane. It's doing these things with annular tanks, like tanks inside of tanks. So it looks like a more interesting design, and it's using a more interesting fuel. So I'm much more interested in seeing what Orbex is doing. But also EBL or ABL, they're supposed to launch from Scotland as well. So it'll be interesting to see who actually ends up launching, or if anybody ends up launching. Rob Loeb asked, "Hi Scott, why do you think SpaceX gave up on catching fairings and just accepted fishing them out of the ocean instead?" And I have a whole video about this that you should probably watch, but long and short of it is that the capture systems weren't reliable enough, and with those giant nets, they frequently got into technical problems in the rough ocean, which made it a danger to the crew. It cost a lot of money to fix them. And the fairings that were recovered from the water were good enough for most of the customers, because most of SpaceX's flight this year have been Starlink satellites. So the Starlink satellites can fly on the restored fairings because the restored fairings don't carry the sound insulation. Other customers do have the vibration, attenuating material, right? So they'll get fresh fairings. Starlink can fly on the reused fairings, and even then they're not recovering them all just because of survivability reasons. So yeah, just economics. Jonathan Lippert says, "Hi Scott, thank you for the time and effort you're taking to answer all our questions. Mine is, How would a human or fish swim in microgravity? Would it be like on Earth? Well, for a fish, it would probably be able to swim around fine, but if you had a fish tank, you would need to have the same attention paid to making sure the water was oxygenated and refreshed and circulating compared to the space station, which has to have fans and ventilation systems that keep the air moving, so that there's no parts where the excess carbon dioxide is building up. The same thing can happen in water, so you'd need to solve that problem. Now, for humans, the problem is humans need to come to the surface, so I'm not sure how that would work. Would you have like a big empty room and a sphere of water, and then they sort of swim around inside to it and they get to the surface? What stops the water from moving that one direction and sort of bumping into the wall? What stops the water from breaking up into individual blobs and you having to swim through and get to the surface? And I think actually surfacing as a human would be quite hard, because when you're coming to the surface on Earth, of course, you come up and gravity pulls all the water off. That's not going to happen in space. So I think swimming underwater, fine. Surfacing, that's going to be a little harder. Now, of course, maybe you just have scuba gear or something, and you're swimming through the water and leaving a trail of bubbles that don't go up or down. Dynamically, it's not a problem. I think the main technical challenges are containing your water in such a way that you don't have it floating around everywhere. Like on Skylab, they actually had a shower, but it was more like it sprayed water onto you, and then you had to suck it all off at the end because it would naturally drop off. And of course, these astronauts, they're real men and they get hair all over. No, never mind. Jonathan. Hey Scott, something I've been curious about for a while. Suppose a sufficiently large cloud of space dust/debris appeared near, for example, the moon. Would it always eventually form a ring like those around Saturn? If so, why, and what's the approximate timescale for that? So actually, first of all, if it were formed out near the moon, that wouldn't necessarily work. But if you formed a debris cloud, say, much closer in, right? Thousands of kilometers above the surface, then yeah, it would inevitably, if you had a bunch of dust, if they're all in different inclination orbits, right, they will bump into each other and they will tend to average out. And they'll tend to average out towards the equatorial plane of the Earth. And the reason is, if you have two things on inclined orbits going up and down and around the Earth at different altitudes, then the equatorial bulge causes these orbits to precess at different rates. So they eventually end up colliding with each other. If you start everything in a single plane, they will get spread out around the Earth, right, due to the oblateness of the Earth. And unless the only place where they're all stable and they don't end up colliding with each other is where they're in the equatorial plane. So yes, it would end up in the equatorial plane. Now, but as you go further out, the moon starts to mess with this. And if you go out to geostationary orbit, then you actually have to expend fuel to stay in the equatorial plane, because the moon is not in the Earth's equatorial plane. It's actually, inclined out of this. It's actually one of the rare, really big moons where it's not in the equatorial plane of the parent body. So anyway, yeah, the geostationary plane gets tilted outwards. So I don't think you would form a ring at that distance. But honestly, I'm not sure. Like, at some point, the perturbations of the moon, you might have a thick plane at that distance and you'll get a thinner plane much further in. But at some point, it's going to get skewed away from the equatorial by the mass of the moon. Andreas Spachmüller says, flight termination systems, how do they work and what triggers them? Well, flight termination systems, the purpose is to terminate the flight. And there are many ways to do this. In some cases, you can just turn off those rocket engines, because why would you want to terminate a flight? You're wanting to terminate a flight because it's going off in the wrong direction and you don't want it flying even further afield, potentially off into inhabited areas. So I know the Proton rocket is one example where they just shut off the engines. The problem with that one is that it actually gets locked out very early in the flight so that you can't shut off the engines when it's very close to the ground because it's full of hundreds of tons of toxic propellant. So in that famous video where the Proton takes off and wobbles and eventually goes off because its guidance system was upside down, that, I believe the flight termination system doesn't really trigger until right at the very end because they had a minimum amount of time to make sure it got far enough away so that it wasn't leaving a huge toxic cloud next to the launch site. Now, other ways of doing this are to literally destroy the tanks, blow holes in the side so that you're making the rocket split into many smaller parts so that it doesn't cause as much damage on the ground. And a lot of US systems have that kind of flight termination capability. And typically what you'll have is either explosives that run along the side of the rocket, typically inside one of the runways where they have plumbing and electrical cabling. You'll have a place in there to unzip the pressure tanks and destroy the rocket. I'm trying to think if there's any other interesting ways of destroying the rocket. I'm sure there's a bunch of other options. Now, what other ways is you just open all the valves as well. I think that flight termination on the Soyuz, they just turn off the engines and everything falls apart, and then they pop the valves automatically. So how they're triggered, though, is that there's a person on the ground that has their finger on a button. And it's not just they push the buttons, they're told, you have to press the button repeatedly because maybe the first signal doesn't go through. That's what I remember somebody telling me that was, they had their finger on the button for a rocket launch. They were told, yeah, you have to keep pushing, push, until you see it explode, right? But the Falcon 9, it has an automatic flight termination system. And with that, it has the launch trajectory is uploaded beforehand. It knows where it should be, where it can't be. And if it ends up going into a place where it can't be, the onboard computers will automatically trigger the flight termination system, resulting in it being destroyed. And this was actually a requirement for the launch corridor from Florida to Sun Synchronous, where it has to take off slightly to the southeast and then curve its way, turn to the south around Miami, and thread its way between some Caribbean islands and end up in a solar synchronous orbit. And that basically required them to have an automatic flight termination system. But also, to be clear, there is also a manual flight termination system on the ground, just in case the automatic flight termination system doesn't behave or doesn't understand what the good place is, where it should be and where it shouldn't. There's a lot more to talk about on this because you've got to think about how does the signal get there. The signals have to sort of be independent of the general vehicle communications because they might have a communications failure and need the flight termination to go via a different system. There's all sorts of interesting parts of the vehicle that can be terminated in different ways. And yeah, explosives tend to be used, but they're not the only thing. If you find rocket parts, by the way, that have fallen to Earth, you should have some concern that there might be unexploded, materials in there. Just because a rocket exploded with a big fireball, that doesn't mean that it generated the kind of shocks that are capable of, triggering modern, explosives. Because modern explosives are designed to be hard to detonate so that they don't accidentally detonate when you don't want them to. Anyway, look, I think this is enough for today. I'll come back in a couple of weeks with some more. Thank you very much. I'm Scott Manley. Fly safe.